All right, try this one out. Come back and check your answer. This one's got an interesting situation where we're relating linear again to the angular theta here and omega. They gave us omega this time, 150 radians per second. They gave us theta. They want us to find the velocity of point P. Interesting. So think about it. How do we get a relationship between the theta and this x, the linear and the angular? That's what we need. And if you think about it, we can split this into two triangles, right? We could come up with a triangle on the left. See if I can draw it here. We could get a triangle on the left here, which would be a right triangle. And we could get a triangle on the right, which would be a right triangle. Right? Now we don't know what this angle is, but we do know what this side is. And we have this theta that we could come up with this length, right? So this one right here, that could be the zero point 0.2 radius cosine of theta, right? Be 0.2 cosine of theta. So if we know that one, then we just need this one. And this one, if we said that this side over here is zero point 0.2 sine of theta, right? Then we've got two of the three sides on the other side. Oh, that was sine of theta. We've got two of the three sides of this right triangle. So this last one over here, we could use the Pythagorean theorem to come up with, right? A squared plus b squared equals c squared. Then we would have this side. It would have to be in terms of theta because of this sine theta on the one side. But then we could add this side and that side. Those would equal the full x in terms of theta. That's it, right? Just a little bit of trig, a little bit of playing with geometry, come up with the relationship between this linear change in length and the theta. Okay, with that, see if you can do the rest and come up with your total equation for x in terms of theta. Then come up with your velocity by doing a time derivative. So here that comes. Our relationship ends up being zero point 0.2 cosine theta, like we said, and then your Pythagorean theorem, where you've got 0.75 as the hypotenuse minus the zero point 0.2 sine theta is this opposite side here, and the adjacent side is the side that we solved it for, right? By square rooting it. So we basically solved it for a squared out of our a squared plus b squared equals c squared. So that is this right triangle, bottom side. 0.2 cosine theta is this left side, bottom side of the triangle. And so then we've got a relationship between the x and the theta, which is what we needed. So take a time derivative of this. It's a little bit ugly, but not too bad. 0 0.2 cosine theta is going to have a chain rule. That's going to become negative 0 0.2 sine theta times the derivative of the inside of the cosine theta, which would be omega, is the derivative of theta. Then we've got this uh, piece over here with the square root. We could think of this as all raised to the 1/2 power, which is what they're doing here. So they multiplied this whole thing times 1/2 to take the derivative of this whole exponent part, which then the 1/2 became a negative 1/2. The inside didn't change, but now we need to multiply it by the derivative of the inside, which the 0.75 squared goes to 0. But this piece is squared, so we'll end up with this 2 getting multiplied down. So we've got a negative 2 when we multiply it by the derivative of the inside, right? We've got a negative 2. The 2 becomes a 1. So this became negative 2 times 0.2 sine theta. That's that. Now, sine theta, or 0.2 sine theta, is inside of that exponent function. So now we need to multiply it again by the derivative of the inside function 0 0.2 sine theta, which would be 0 0.2 cosine theta. But sine theta is also a function with a function inside of it, theta. So now we need to multiply it by the derivative of the inside function, theta, which is omega. So we had functions inside of functions, so lots of chain rules, but that's what we get. And from there, it's all plug and chug. We're solving for VP, the velocity of this piston. So they gave us theta of 30 degrees. They gave us omega of 150. So solve that by plugging in theta and plugging in 150. And that's what you should get is negative 18.5. So it'll be moving to the left at that instant. Okie doke. So that's a pretty good one. Make sure you understand how we set up that relationship, because really that's the key part of this. After that, it's just making sure you do your chain rule and do your derivatives correctly.